Before we get into 12.7b, I thought it'd be a good idea if we reviewed the 6 trig parent functions. So the first one we should review is y equals sine of theta. Alright, so in the first half of the lesson you learned that the amplitude was 1, and the reason was because there's an invisible 1 here, and you take the absolute value of that, and the absolute value of 1 is 1. The period for sine and for cosine is usually 360, and for this parent function it's 360 because there's another invisible one. This is your b value right there. So you take the b value and that goes underneath 360. So the period is 360 degrees or 2 pi radians. Alright, so that's already labeled on the x-axis. The amplitude is not labeled on the y-axis, so let's just call this point positive 1, and we'll go down the same distance. This is negative 1. Alright, so for sine, if you think about the unit circle, sine at 0 is 0, so it starts here. So when I was growing up, my parents' house had 3 levels. You would walk in the front door and you'd be like on the ground level, and then you could either go upstairs or downstairs from there. So that's kind of how a sine graph works. So usually I would come home, I'd start on the ground level, then I would go upstairs to my room. And if you wanted to go to the bottom level, well, you can't go to the bottom level unless you go back to the middle level first. Then you could go to the bottom level. So just imagine you start out on the ground, then you go up. You can't go to the bottom unless you go to the middle first. Alright, so 3 levels. Starts in the middle, then up, back to the middle, then down, then back to the middle. Alright, so now we're going to show you what the reciprocal of sine looks like. The reciprocal of sine is cosecant. So on the same graph, so you could see how they're related, I'm going to graph y equals cosecant of theta. Alright, so first thing I want you to look at is these 3 spots. At those 3 spots, sine of theta is 0. Cosecant is the reciprocal of sine. So what happens when sine theta equals 0? The reciprocal of 0 is undefined. So at these 3 spots, you're going to have asymptotes. Okay, now I'm going to go here. When sine is 1, the reciprocal of 1 is also 1. Now I'm going to go down here. When sine is negative 1, the reciprocal of negative 1 is also negative 1. Okay, recall that asymptotes are lines that the graph gets closer and closer to but never touches. So now I'm just going to draw these things that look like parabolas that shoot up toward the asymptotes. Alright, so in red you see the graph of y equals cosecant theta. And going back to the sine graph, remember to put arrows on the end because these keep going forever. Alright, now let's move on to y equals cosine of theta. that also has a 1 in the front of the cosine. So the amplitude will be 1. It also has an invisible 1 in front of the theta. So the period is going to be 360 divided by that invisible 1. For sine and cosine, I like graphing a whole period, which we already have on the x-axis. Let's label the y-axis with the amplitude. So this is 1. This is -1 down here. Okay, now imagine the same house. It has 3 levels. There's a middle level, and you could go upstairs or downstairs from there. So imagine the same house, but imagine your cousin lives upstairs. So cousin is cosine. So cosine or cousin always starts out upstairs. And when you're at the top, there's only one place you can go. You have to go to the middle. And then from the middle, then you could go all the way downstairs. And then from there, you have to go back to the middle. And then you could make your way back up to the top. Sine and cosine follow the same cycle, just at different times. You could always go top, middle, bottom, middle, top, middle, bottom, middle. They both follow that cycle, just not at the same exact time. Alright, so let's make it a smooth wave. And put the arrows on the end, because these are going to keep going. Alright, so on the same graph, I'm going to graph the reciprocal, which is y equals secant of theta. Alright, so first thing you do is find when cosine is 0. What's the reciprocal of 0? Undefined. So whenever cosine is 0, secant is going to have an asymptote. And then go to 1. The reciprocal of 1 is also 1. Reciprocal of -1 is -1, and we have another 1 here. And so whenever you're at 1, you're going to go toward the asymptote up towards infinity. Whenever you're at -1, you're going to approach the asymptote on the bottom. So that's what a secant graph looks like. Okay, tangent is a little more complicated. So for tangent, I actually prefer to graph 2 periods, and I'll show you why after I graph it. So this is y equals tangent of x, no, tangent of theta. Alright, it doesn't have an amplitude, but we do still use the number in front of tangent, and in this case it is 1. So it's kind of like an amplitude. We still use those numbers, 1 and -1. Alright, so what I do for tangent, the period for tangent is 180 degrees. It's 180 divided by the number in front of theta. And so for tangent, I like graphing 2 periods, so 360 degrees or 2 pi. Alright, so we already have 2 pi on the x-axis, and notice that gets cut in 4. If you take 2 pi and cut it in half, you have the pi in the middle, right here. You have pi in the middle, and then that gets cut in half, and then there's this midway point over here. So 2 pi gets cut into 4 slices, like the quadrants. Alright, so if you have a tangent graph, and if you graph 2 periods, and then cut it in 4, The first and the third will be asymptotes. Again, if you have two periods of tangent, which in this case is 2 pi, so one period is pi, so 2 periods is 2 pi. Take 2 periods, which is 2 pi, and then cut it in 4. The first and the third cut will be your asymptotes. Alright, the numbers on the x-axis labeled, those are going to be your zeros. So there's going to be a 0 here, a 0 here, and a 0 here. Alright, and then from there I like to cut it again, so it's like cutting it into eighths. So I cut it here, 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 and here. And let's label those. So this would be a lot easier if it was in degrees. So in between 0 and pi over 2, that one is pi over 4. In between pi over 2 and pi, that would be 3 pi over 4. And maybe you could see the pattern. This one will be 5 pi over 4 and 7 pi over 4. Okay, so one thing you should know about tangent, it is increasing. So tangent always goes up from left to right. So I'm actually going to graph this middle area first, so in between here and here. Okay, so tangent is increasing from left to right. So at 3 pi over 4, that's when it's going to be low at -1. Then it's going to hit here. Then it's going to go up to +1 when the x is 5 pi over 4. So tangent graph will look like this. So this is a complete period in the middle. And so now we have 2 half periods on the left and on the right. So this is I'm going to the left. This is the positive part of a tangent period. So it looks like that. And then at 7 pi over 4, that's when you're at -1. Okay, now let's graph cotangent of theta. Okay, so remember, when tangent is at 0, the reciprocal of 0 is undefined. So when tangent is 0, cotangent is going to have an asymptote. So we have an asymptote here, another one here, and one here. Okay, what else do we know the reciprocal of? The reciprocal of 1 is 1. So anytime tangent is at 1, cotangent will also be at 1. The reciprocal of -1 is -1. So cotangent and tangent will share those points. Alright, what else can we flip? Well, when tangent is undefined, the reciprocal of undefined is 0. So when tangent has an asymptote, cotangent is going to be at 0. So we could put zeros here and here. Alright, that looks very chaotic having 2 graphs on one. So try to ignore all the blue and only look at the red. So now try to imagine a tangent graph but mirrored. So instead of increasing, it's decreasing. That is what cotangent will look like. So the same exact shape, but instead going down from left to right. This will go start up and then go down. And we have 2 complete periods. Okay, so those are the parent graphs, and we'll review some more as we do some examples of the non-parent graphs. All right, for number 1, we need to graph y equals 1/2 cosecant theta. So this is easier to see. I'm going to first graph y equals 1/2 sine theta. So that would have an amplitude of 1/2. But cosecant has no amplitude. So we put those numbers on the y-axis. And now the period for both of these would be, we have to take the number in front of theta and put that underneath 360. So the period would be 360 degrees. So I'm going to put that on the x-axis. And now I'm going to cut this into 4. So I'm going to cut it in half and then cut each of those in half. So 360 divided by 4 is 90 degrees. Okay, so remember sine it starts at the middle level, then it goes upstairs, then back to the middle, then goes downstairs and back to the middle. All right, so there's your sine graph. And so now in red, I'm going to graph y equals 1/2 cosecant theta. Okay, so whenever sine is at 0, it's an asymptote. Then I'm also going to copy the point at the what looks like the vertex here and here. Alright, so you might be asking, why do those share the same point? The reciprocal of 1/2 is 2. So the way I would explain that is looking at sine of theta and cosecant of theta, those functions are reciprocals of each other. So those equal 1 at the same point, at the same time. But then notice 1/2 and 1/2, these are not reciprocals of each other. So think of it this way. These equal 1 at the same time, and then if you multiply both of them by half, they'll then equal half at the same time. It's kind of complicated. So just imagine that you can take the sine graph and then draw parabolas at both vertices, I should say. Alright, so in red we have our graph. The blue doesn't need to be there. You could erase it if you want, or you could keep it. Okay, so for number 2, we have a secant graph, which is similar to a cosine graph. Well, I shouldn't say similar. It follows a cosine graph. Alright, so first thing I'm going to write is the period. Notice the b value is 3. So we're going to take 360 and divide by 3. So that's 120 degrees. So I'm going to put that on the x-axis. And I'm going to cut it into 4. 120 divided by 4 is 30. Alright, now secant does not have an amplitude, but if this was a cosine graph, it would have an amplitude of 1. So we still use those numbers, 1 and -1. Alright, so if this was a cosine graph, remember cosine starts upstairs. It would hit here, then to the middle, then to the bottom, because we haven't gone there yet. From the bottom, you always have to go back to the middle, and then here. Okay, so if you want to connect those with a wave, that would be the cosine graph. So this one looks less complicated. I'm not going to connect it. So remember, when it is at 0, it's going to be an asymptote instead. So I'll label both of these zeros as asymptotes. Then you're going to have those parabolas. So this parabola is going to open up. This parabola is going to open down. And we have another half up. That one I didn't draw the cosine graph just so it wouldn't look as cluttered. Okay, for number 3 we have a cotangent graph. So the period. So for tangent and cotangent, you take the b value and you put it under 180. So 180 divided by 2 is 90 degrees. And then remember, for these, I like to make 2 periods on the x-axis. So even though the period is 90, I'm going to do 180. So then I cut that in 4. So these will be 45 degrees each. And again, there is no amplitude, only sine and cosines have amplitudes. But we're going to use the number in front, -1 and 1. Okay, so I taught you that the first and the third are asymptotes for tangent, and it's backwards for cotangent. So for cotangent, the first and the third are zeros, and then the other ones are asymptotes. So if you have 2 periods of tangent, first and the third, so 2 periods of tangent, cut it in 4. First and third will be asymptotes. 2 periods of cotangent, it's opposite. First and third will be zeros. Alright, and then I'm going to cut these increments again, but I won't write the numbers because they'll be ugly decimals. So I'm going to cut it in all these middle spots. And why am I doing that? Because that'll show us when we will hit the 1 and the -1. So tangent is the graph that rises, cotangent is the graph that falls. So cotangent starts at 1 and then goes to -1 as you move to the right. So starts at 1, goes down to the middle at 0, and then down to -1. Alright, so we have 2 periods of cotangent 2 theta there. Alright, on the back, let's review a cosine graph. So this has an amplitude of 1. So we go up to 1 and down to -1. The period for this is going to be 360 divided by 2. So the period is going to be 180. We want to cut that in 4. So these will be an increment of 45 degrees. Cosine starts upstairs. So top, middle, bottom, middle, and back up to the top. Alright, make a smooth wave. And this is going to keep going. Alright, so cosecant is going to follow a sine graph. No amplitude, but again, we want to use these numbers because those are our key points. So 3 and -3. And the period is 360 divided by 3. So the period is going to be 120 degrees. Put that on the y-axis. Cut it into 4. So we're going to count by 30s on the x. Okay, so sine is the reciprocal of secant. Sine starts at the middle. So I'm going to graph the key points for sine. Sine starts at the middle, then goes upstairs, back to the middle, downstairs, and back to the middle. So I would connect that if I was doing a sine graph, but I'm not doing a sine graph, I'm doing a cosecant graph. So for a cosecant graph, make your asymptotes whenever it's at 0. Then you make your parabolas. So if there's a point that's positive, make your parabola going up. And it's technically not a parabola, I don't think, but I'll just call it that. Alright, we're going to do more of the same, but now we're going to practice in radians. Okay, for number 3, amplitude is 3. So we go to 3 and negative 3 on the y-axis. Our period, they don't ask for it, but let's write it anyway. So remember, the period is you take the b value, and usually you put that under 360, but this is in radians. So what's equivalent to 360? 2 pi. So we're going to take 2 pi and divide it by the b value, which is pi over 4. Alright, so notice instead of theta, they used x, but x is just the angle. Alright, so the pi's are going to cancel, and we're going to end up with 8. So that's kind of weird. It seems like it's almost not in radians because there's no more pi. So this is just going to be an 8, no more pi. Cut that into 4. So each tick mark is going to count off 2 units. Okay, so sine starts in the middle and goes up from there. So middle, up, middle, down, back to middle. Alright, for number 4, notice we have a negative 1 in front. So we're still going to use 1 and negative 1. The period for this, we're going to take 2 pi and divide by the b value. The b value looks like it is pi. So the period is 2. So 2 goes there. We cut that into 4. So these are going to be half units. Alright, so what's the reciprocal of secant? Secant is cosine. Cosine usually starts upstairs, but because there's a negative, this cosine is going to start downstairs. So I'm just going to hit the key points. Whenever you're downstairs, the only place you could go is back to the middle. And where have we not gone yet? We haven't gone to the top. Now we have to go back to the middle and then to the bottom. So remember the cycle. It's always top, middle, bottom, middle. Top, middle, bottom, middle. Started at the bottom, so it had to go to the middle next. Alright, I'm not going to connect it because that's a cosine graph. Alright, so I'm going to draw the asymptotes whenever we're at 0. And then I'll draw the parabolas. So I could fit a whole parabola in the middle. And a little half parabola on this side. And another half parabola there. Okay, what's the period for tangent? Period is, you don't take 2 pi and divide by b, you take just pi and divide by the b. So the b value looks like it is 1/3. So this period is going to end up being 3 pi. So remember, I like graphing 2 periods. So I'm going to graph 6 pi on the y-axis, or sorry, on the x-axis. Let's cut that into 4. 6 pi divided by 4 is 3 pi over 2, so the halfway will be 3 pi. This will be 3 pi over 2, and then 3/4 of the way will be 9 pi over 2. Alright, tangent and cotangent both do not have amplitudes, but we're going to use that a value anyway. So we want 1 and -1. Okay, so whenever you graph 2 periods of tangent, the first and the third quarter will be asymptotes. And so tangent usually rises, but because there's a negative in front, this tangent graph is going to be decreasing. Alright, so what do I usually do after I make the asymptotes? Then I cut it again, but I won't bother labeling it because it'll get too crowded. Alright, so we know that in the middle is going to be the zeros. So before we cut it into eighths. Alright, and my graph isn't exactly to scale, but that's alright. Alright, so these are going to decrease. Let's start in the middle. So again, usually tangent goes up from left to right, but because of the negative, it's going to go down. So at this point, I want to be at 1, and then at -1. So the points on the left of the 0 are going to be up at 1. The point to the right of the 0 is going to be at -1. So in the middle, we can draw a complete period of our tangent graph. Over here, I can draw a half period, and same thing, I can draw another half period there. Okay, so tangent rises from left to right, cotangent decreases from left to right. Unless there's a negative in the front, then it's backwards. Okay, for tangent and cotangent, you do 180 divided by the b value, or pi divided by the b value. The b value is pi over 2, so the pi's cancel. There's a 1/2 on the bottom that gets flipped. This has a period of 2. So for tan and cotangent, I like graphing 2 periods. So I'm going to put a 4 there. And these will count by 1. 1, 2, 3. Alright, the a value is 3, though it's not called an amplitude again, because only sine and cosine have amplitudes. Okay, what did I teach you guys? Tangent, if you graph 2 periods, First and third will be asymptotes. For cotangent, it's the other way around. So first and third will be zeros. 0, 2, and 4 will be asymptotes. Alright, and now I'm going to cut it again. So why am I doing this? These points are where we're going to have 3 and -3 as y-coordinates. So cotangent goes down from left to right. So we need to start high at +3, then we go to the middle, and then we go down to -3. Same thing here. Start high, go to the middle at 0, and then down to -3. Alright, that's all for this very long lesson, which is an important one for next year, so make sure you learn this well.